here's the review for the Chapter 3 exam. So the first question asked me to find equations of all lines having slope of -1. So I know that I have the slope of the tangent line, which tells me to find so to write the equation of the line, I need ordered pairs and slope, right? So I have the slope already, which is great, but I need the points that have the slope of -1 to this curve, right? So I'm going to find the derivative. I'm going to set the derivative equal to -1 because that's the slope, and then solve for x. And then once I get those x's, I'm going to plug them into this equation to get the y coordinates so that I can have x1, y1. Right, so I already have m, and I have a feeling there's more than one line. So I take the derivative of this, so I rewrote it as y equals 9 times x minus 4 to the -1. And then I took the derivative, so dy dx equals -9 times x minus 4 to the -2. So I moved the -1 to the front, made that a -9, down 1 on my exponent, multiplied by the derivative of the inside, which is 1. So I ended up with -9 over x minus 4 squared. All right, so I know this is equal to -1. This is my expression for the slope at any point. I want the slope at -1. So I set that equal to -1. I'm going to cross multiply. So -9 equals -1 times x minus 4 squared. I divided by -1 on both sides. So 9 equals x minus 4 squared. Square root of both sides. So plus or minus 3 equals x minus 4. So I have two equations. I have x minus 4 equals 3. X minus 4 equals -3. So this one x is 7, and this one x is 1. So I have the x coordinates for the point where the line is tangent to the curve with a slope of -1. So I have 1 something and 7 something, so from these two. So I go back to my original equation and plug in x and find y. So 9 over 1 minus 4 would be 9 over -3. And that's -3. And then 9 over 7 minus 4 is 9 over 3, and that's +3. So now I use point slope. So I have 2 points. I have slope. So I'm going to write two different equations. All right, so that's how you do that one. Number 2, I'm going to find the derivative of this equation and then plug in -3. So the derivative of this equation, this should be super fast. Derivative of 1 is 0. Derivative of -9x squared is -2 times 9x. So -18x, and then plug in -3, which is 54. Number 3, we're just finding the first and second derivative, dy dx. So when I scan this, there's no product rule, no chain rule, no quotient rule, it's just straightforward. So derivative is 8x minus 10 plus 18x to the -3. So moving this to the front, multiplying down 1 on my exponent. All right, number 4, I see product rule twice. So I have product rule here, product rule here. I don't have to do product rule here because the 16 does not have a variable with it. All right, so that's a good thing to scan before you start. All right, so dy dx is equal to first times derivative of the second plus second times derivative of the first. So derivative of 18x squared would be 16x. All right, so I'm through with the first one. The second one, product rule again, first times derivative of the second plus second times derivative of the first. All right, then the last one, no product rule, so -16 cosine x. And I didn't have to do chain rule because my angles were just x. All right, chain rule on number 5 though. Oh, I didn't do the second derivative on number 3, sorry. D squared y over dx squared equals 8. Derivative of negative 10 is 0. And then negative 54 x to the negative 4, sorry. All right. Just checking my notes to make sure I got everything down. Okay. All right. So number 5 is chain rule because I see my angle is not x, it's other things. But it is not product rule also because this doesn't have a variable with it. So dy dx is 1 over 36 secant squared 6x minus 1. So derivative of the trig function, leave the inside alone. And remember that angle never changes anyway. And I'm going to multiply that by 6. I can move the 6 to the front so I can reorder everything. So 6 over 36 is 1 over 6 secant squared 6x minus 1. All right. I want the second derivative for this one. It looks like I only did the first derivative on my paper, so cool. Second derivative for this, dy dx. This I see product rule and chain rule, power rule, chain rule. All right, so first times the derivative of the second. So 8 to the front, down 1 on the exponent, leave the inside alone, multiply by the derivative of the inside, plus second times derivative of the first. And then we could clean this up, so this would be 6x to the 7th, 48 when I put those two together. So 8 times 6 is 48. X squared times x to the 5th is x to the 7th. And then I will leave x to the 6th minus 3 to the 7th plus 2x, x to the 6th minus 3 to the 8th. And then you could do product rule again. You have some options, like we could simplify and then take the second derivative, but we can just do the second derivative from there. So I'll leave that for you to do. Number 7 is formula for tangent inverse and cosecant inverse. And so I have dy dx equals 1 over the angle squared. So 1 plus the angle squared, so the square root of 16x squared minus 1 squared, and then I multiply by the derivative of the angle measure, and so that would be 1/2 times 16x squared minus 1 to the negative 1/2 times the derivative of the inside of the angle, so 32x plus, and then I'm working with cosecant here, so negative 1 over the absolute value of the angle times the square root of the angle squared minus 1 times derivative of the angle. All right, I'm leaving it like that. I'm not cleaning it up. You can clean it up if you want to, but please don't waste time on that tomorrow. Number 8, just super quick, and these are, number 9 is on Canvas, so you can check that out. We talked about that quite a bit yesterday. So derivative, find 2 points where the curve crosses the x-axis, so that means I already know y is 0 at those points. Tangent lines to the curve at those points are parallel, so I'm looking for the slopes of those. So I take the derivative, so 2x plus 7x dy dx, so product rule here, plus second times derivative of the first, plus 2y dy dx. So remember, every time you take the derivative of y, we have to put dy dx. All right, so I have 2 dy dx terms, so I'm going to keep those on this side, so 7x dy dx plus 2y dy dx equals negative 2x minus 7y. And then factor out the dy dx. And then divide. All right, so now it's asking for the slope at that point. Well, first of all, I already know that y is 0. And so I can plug in 0 for y, and I end up with negative 2x over 7x. So my slope would just be negative 2 over 7. I worked it two different ways. I worked it that way. And then I also graphed this on Desmos, looked at where it hit the x-axis, pulled those x coordinates off, and plugged them in, like plugged in x and y. But you still end up with negative 2 over 7. So this is probably the fastest way to just go ahead and plug in 0 for y, and then you're left with negative 2 over 7. Yeah, and there's only 2 points where it's x-axis, so that's it. And then number 9 you can check out.